keep saying this, for voltage, amplification, voltage, signal processing, you needed to drive from low impedance, basically the current output impedance is much smaller than next stage's input impedance. Next stage needs to be high impedance. Did you realize why? If I did not satisfy that rule, what happens? You obtain a gain without loading. When you attach the load to your output node, the gain will drop. Can you see? The gain will suddenly drop, will no longer be the open loop gain, or when you evaluate a pickup truck, one is the performance without any loading, another is with loading. You want to make sure with loading you still can run fast. So for that reason, this rule holds. We needed to make sure the current stage's output impedance is much lower than next stage's high impedance, input impedance, okay? So that's one part, it's called terminal gain, GM multiplied by RL, and there's a negative sign indicate common emitter amplifier output signal is out of phase compared to input signal, okay? But there is an input loop transfer function. So input loop, you go from source to the base terminal. Here is your VB. How can I find out VB? You take VI, let me go from here, VI, right? Divided by total impedance on the loop, that will be Ri plus the final output. Who is doing that job? Well, you have the receiver, it's your baseband. Your receiver has a baseband chip, it has a feedback, come back to the RF transceiver to control the gain, okay? And if I use a bipolar transistor, the good news is I can easily tune the bias current and make the gain linear change. But in most case, unfortunately, it's proportional to square root of ID. Can you see? A little bit harder, okay? So bear in mind, but this is the equation you should use. Kn should be given normally. Input resistance for bipolar transistor is R pi. R pi is equal to beta times 1 over GM. And we talk about the shape of PN junction, base emitter junction. You look into the base, is high impedance because current is small. Look from the emitter is low impedance 1 over GM because current is huge. And this is R pi. Both R pi and 1 over GM describe the base emitter junction resistance, but it's from different angle. One from top, another from bottom, basically. We look differently. For most